So if we look at AMR fleet in 5 to 10 years, there's huge potentials. One of them is using AI and expanding above the current planning and optimization approaches and really opening up to an AI ecosystem, allowing customers and partners to bring in their own applications and work together with us to make sure that our fleets are commanded and operated in the most efficient way. Another topic is interoperability. That's basically to bring together AMRs, manual transports, and all kind of third-party vehicles to create a smooth traffic experience and to optimize workflows. Flexibility can also be thought on a wider scale. So this means AMRs really roaming around between different applications, moving wherever they are needed the most at the moment. And this would allow our customers to really adjust based on peaks or high demands in certain times, and AMRs to be flexible and go wherever they are needed the most.
When we look at the next 5 to 10 years, I think that could be also raised up, not just to talk between the AMRs, so maybe also between AMRs and robots. Simulation and visual commissioning will help to identify risk very early, which means that we can reduce any more efforts in our detailed planning for these projects. Even with more automation, the current human will be needed for maybe problem solvers or also supervisors.
So the big step will be moving from just a fleet manager that can manage a fleet to a manager that can manage not only the fleet, but all the automation that we have inside the plant. So we can manage the AMR that can work together. So one AMR can be the master of the other AMRs. We can merge the AMRs with the drones, because we expect to have drones in some sectors like intralogistic and logistics. We expect AMR that can work and interact with the robot itself. So the fleet manager of the future is a fleet manager that is not only able to manage AMRs or a mobile robot, but is able to manage a lot of systems altogether. Another step ahead that is already started, with KUKA already started on it, but it will have an explosion. It will be very important in the next future, is the combination of mobility and manipulation. So AMR equipped with a cobot or a robot on top to optimize handling tasks. So to feed machine, to collect boxes, to move from one side to another. So using the AMR task with the robot stability, it's something that it will be part of the next future, everything orchestrated by the fleet manager of the future, of course.
If machines communicate together throughout the whole process of factory planning, it starts really in the planning phase, where the machines and all our systems are connected and can be simulated throughout the whole customer journey. So this means in the beginning, we have a simulation with all the relevant machines and data, and we bring this data and the experience there also into the commissioning and operation phase. Another example is to connect to customer systems. We have a flexible approach to connect, for example, to MES systems of our customers and to all other kinds of equipments, allowing different systems to speak together and optimize the total workflow. Our focus as KUKA is to provide the whole customer story with our products, starting from simulation with visual components and bringing these learnings also into the commissioning and operation phase, allowing our customers to save time and money and learn throughout the whole process.
The current factory planning is very static in the layout right now. For the future, it has to be more flexible and more interacting between our machines. Simulation and visual commissioning will help to identify risk very early, which means we can spend a lot of money to reduce these failures. Within the new VDA 5050, it's already today possible to interact between different AMR suppliers, to have one big fleet out of different suppliers just controlled with one fleet management.
Factory planning is moving from a static and deterministic model toward a continuous evolving system model. The traditional factory are based and designed on fixed layout and predefined flow. Thanks to the introduction of the AMR into the production plant, we can redesign the layout, make them more dynamic, make them more ad hoc production oriented to optimize the throughput and to give a suggestion to the operator how to increase. Also, the role of the humans will change in a bit. The humans so far will be just let's say, a humanized AMR or humanized robot. They push a button, they optimize a task, they don't interact so much with the automation system that there are in the plant. Thanks to the AMR, thanks to the digital twins, and thanks to the AI-based software, there will be a continuous interaction between humans and the machines in general, where humans can hand over points and tasks to the AMR or to the robot system into a factory to accomplish the task all together and no more separately.
So if we look at the potential of AMR in the production architecture, we see big chances to increase the efficiency if you look at 24/7 operation, if you look at challenges of our customers with labor shortage, and also to allow processes in environments that are not suitable for persons. For example, in cleanroom applications or hazardous areas. And for this, we provide very suitable products like the KMP 250P cleanroom and also our KMR series.
The AMRs today are mostly seen as just an add-on in our processes. In the future, I think that AMRs has to be integrated as an integral part in the whole production architecture, as a scalable modular backbone that dynamically connects stations, buffers, and also processes.
The key idea behind, according to me, is that AMR shift the production from a static optimization to a continuous flow optimization. What does it mean? It means that we have to stop thinking about AMR as just a smart forklift, but we have to start thinking them as an orchestration layer among the production system. To do that, we have also stopped thinking about AMR as just a transportation of goods from one side to another, because the AMR can optimize the flow, can reduce the bottlenecks inside the plant and prioritize the orders. This is the first point. The second point is that we have to start thinking AMR also as a way to eliminate the traditional inventory of the buffer inside the plant. But thanks to the AMR, we can enable the optimization of the buffer flow, reduce the work in progress, and work in a just-in-time mood. In that way, we can free up space inside the plant. We can reduce the work of the labor that we have inside, and then optimize the throughput of the production.